Good evening, everyone. My name is James Palsick. I'm here with Science Safety. And of course, Dr. Ken Roy is here as well. Both Dr. Ken and myself will be facilitating tonight's session. We are very well versed, recognized as academic and practical safety educators, specifically in the areas of STEM. And we do have extensive knowledge about the legal safety standards and better professional safety practices to help you meet both your compliance and professional objectives. Now, tonight's session is largely to do with chemical health and safety, recognizing those chemical concerns in your schools, because the reality is chemicals do pose potential safety hazards. And regardless if it's in a formal laboratory or in a science instructional space, which Dr. Ken will touch on this evening, that responsible chemical management definitely begins with having a comprehensive and thorough understanding of what that really means and what's involved with that. And the most important piece is clear and consistent communication across not only the school, but also the entire district.
Huh.
How does that sound, Ken? Pretty
Right
good.
on, right on, brother.
So let's explore some of these safer strategies when exploring chemical concerns in schools. So before we begin, it is my privilege and my honor to introduce your featured speaker, Dr. Ken Roy, who is the Director of Environmental Health and Safety, the Chemical Hygiene Officer, or CHO, the Designated Asbestos Compliance Coordinator, the PCB Program Coordinator, and the Silica Compliance Coordinator at Glastonbury Public Schools in Connecticut. In addition to those roles and responsibilities, Dr. Ken is the Chief Science Safety Compliance Advisor and Chief Safety Blogger for the NSTA, or the National Science Teaching Association, and the Safety Compliance Officer for NSELA, the National Science Education Leadership Association. In Ken's free time, I love that term, he has managed to author 13 science and STEM safety books and over 850 safety articles in professional journals and associations, including the NSTA, NSELA, CS Cubed, ITEEA, and many more. It is a pleasure to welcome you tonight, Dr. Ken.
Thank you.
And I am James Palsick. I am the former GM and Director of Education, Safety, and Compliance for Flynn. I am with Science Safety and Ed Circuit. I have only authored 3 science and STEM lab safety books. I'm trying to catch Dr. Ken for the COSSS and multiple chemical hygiene plans for schools. I'm also the safety reviewer for the Perimeter Institute for Theoretical Physics, which is a renowned global think tank focusing on physical science. And I've appeared on more than 150 podcasts and written articles on science education, safety, and better professional safety practices all across science, STEM, and CTE, and many of those you can find on edcircuit.com and others. Okay, time for the big show, Dr. Ken. It's all yours.
Okay, well, first of all, I want to welcome everybody this evening, taking time out of your busy days, as I'm sure you have this time of the year, to take a look at some of these very, very important things that you need to be aware of if you're not, and if you are aware of, and to help you better prepare to deal with them. Chemical concerns. Responsible chemical management involves a combination of the following key criteria, which are connected to overall safer practices in hygiene in your school. Now, notice we use the word safer, and I always like to focus on that. The first thing I want to tell you is you can't make it safe. Okay, people get nervous when I say that. They know, well, then why are we doing all this stuff? Because you can make it safer, but there are no guarantees 100% that you're not going to have an accident. Accidents are many times unanticipated, most certainly. But you want to bring the frequency of that possibility down. So we can, using safer practices in hygiene in school. So let's take a look at some of the criteria, all right? Chemical hygiene plan, absolutely critical. Yes, you must have a chemical hygiene plan if you teach, instruct in a laboratory instructional space, okay? And it needs to be up to date. Up to date means annual, okay? Very important. It involves protocols, safety, legal safety, better professional safety practices, et cetera, et cetera. So very critical. And it's there to protect you. And even though OSHA requires this, it's still better professional safety practice if you're not under OSHA, so it still needs to be done. And it'll also certainly help better protect students, but it's mostly focusing with employees. Up to date chemical inventory. That doesn't mean one that you blow the dust off of 10 years ago, right? Again, every time you receive new chemicals, you add them to the inventory. Again, every time you purchase or receive new chemicals, you put them in the inventory and the additional information that's required, right? That's update, not waiting years. Appropriate chemical storage, absolutely critical. You need to know what you're storing. You need to know if it's stored appropriately, and you need to know when to get them out of Dodge, all right? Because some chemicals, over time, right, they get ugly. Potentially, they get ugly. They can become explosive, in fact, in some cases. Picric acid is a prime example, right? So you need to be very careful that you have appropriate chemical storage. Chemical usage, appropriate usage. Are you following the protocols that are set up by your school's administration or Board of Education, whatever the governing bodies are, right? Want to make sure you're doing it. And if you do not have the appropriate engineering controls, if you don't have the chemical hygiene plan, if you haven't had the training, you should not be using those chemicals in your lab, because if something goes south, you're going to be hit legally. So you always want to make sure that all those things are in place before chemicals are used. Chemical labeling and safety data sheets, SDSs, right? Again, you need to have appropriate labeling. OSHA well defines labels, what needs to be on them. And certainly you're required to have SDSs for every one of those chemicals that you have. Chemical waste management. Okay, you bought it, you stored it, you used it. The end of the cycle is getting rid of it. You know how to get rid of it? You should have thought about that before you purchased it. Do you have the capability of safely getting rid of the waste? And you just don't let it hang there again for years and years. Put it in the back of a cabinet and forget about it? No. All right. Again, you can have explosive type situations. So you just don't want to do that. Chemical purchasing and ordering. All right. Actually, the chemical hygiene officer is the one that really should be the one to approve that situation. In other words, whenever you want to purchase chemicals, you want to make sure you can determine, is there a real need for it? How am I going to use it? And make sure that chemical hygiene officer supports that. Chemical hazards and PPE requirements. PPE, personal protective equipment. Are you using indirect event chemical splash goggles? Not safety glasses with side shields when you're dealing with liquid hazards. If they're solids, like maybe you're working with spring, like in physics, for example, working with springs, projectiles, et cetera, those you can use safety glasses. But generally in chemistry and biology, you're looking at greater use of things that are not glasses, all right? Okay, chemical safety training. Critical, absolutely critical. Again, before you use the stuff that is hazardous, you need to have appropriate training. And again, under OSHA, this is required by your employer. And if your employer is not doing it, you need to send them something in writing, which is another whole story. Always give the administrator, you need something relative to safety, always give it to them in writing. Absolutely critical. So you have the history there. You have a record, the written word. Next. Okay. Now, here's the lab situation. Things kind of look a little tidy bowl for the most part. And you want to make sure that things are. Unfortunately, if this was a K-12 laboratory, there would be some issues. One of the issues is access students to hazardous chemicals. You would never leave things like this out that are unsecured, because if they take them home, or they take them even to another part of the school, somebody gets hurt, you got legal issues, big ones, because they can get very severely hurt, right? So you have to be very careful with that stuff. You also need to make sure you have appropriate electrical connections, all right? In other words, ground fault interrupt, GFI protected, all right? Again, if you're using extension cords, you want to make sure at the end of the workday that they are disconnected, because sometimes what happens is, especially if you have the wrong gauge on them, they overheat. If you leave them plugged in overnight, you'll come back to ashes, right? So you need to be very careful with that. The other thing is you want, okay. Ooh. The other thing you want to make sure, when again mentioned, that you have appropriate PPE whenever you just are going there, preparing for hands-on work. The first thing you do is get on the PPE, the gloves, the goggles, the aprons, etc. You don't gather everything and then put it on when you're doing the hands-on. Remember, there's three pieces, right? There's the gathering of the materials, the hands-on, and then doing away with everything, putting everything away, the takedown, as we call it, all right? Through all three pieces, you always have on your PPE. Next. Okay, chemical hygiene plan. Ensure that all members of the science department have access to a current, there's that word again, current chemical hygiene plan, which contains necessary standard operating procedures for responsible chemical management in the school. This is for science department and managed by your designated, here we go, the chemical hygiene officer. That's their job, okay? And you may have more than one. Some school districts, depending on the size, if you have several high schools, for example, that are very large, more than likely you'll have several chemical hygiene officers. You may have them in middle school. Wherever you have formal laboratories, you're under the laboratory standard. Now, if you're in an elementary classroom, even if you are using hazardous chemicals, you don't use anywhere near as many, obviously, as in a formal lab, you would be under HAZCOM. As it states in the next piece here, other departments will use a hazard communication plan or standard, such as art, CTE, cosmetology, agricultural science, and others, with access to potentially hazardous materials during the course of the workday. Again, the numbers, the severity of those hazards usually are less, right? It's still dangerous, however. Still dangerous. Okay. For information, your chemical hygiene plan needs to be reviewed at least annually, which I've already stated. Science Safety can review your existing chemical hygiene plan and make recommendations based on our risk management matrix. Great servicing. This is just a really good piece, because a lot of times you have situations where people that are dealing with this stuff have not a full background or understanding of what needs to be done, especially if it's the first time it's being done. It's a good idea. Next. Having a chemical hygiene plan is central to responsible chemical management. Yes, across the entire school district. This is regulated under OSHA. Now, CFR, Code of Federal Regulations, 291910, General Industry, and 1450 is the laboratory standard. You have standard operating procedures, employer control measures for hazardous chemicals. In other words, what are the required PPEs? Again, this is all part of the plan, right? What are the required PPEs? What are the administrative controls? Better professional practices, in other words, that type of thing, safety-wise. And engineering controls. For example, you have the appropriate ventilation. And ventilation in laboratories is much different than general classrooms. General classrooms, you generally have the intake of about 20% fresh air. Laboratories, 100% fresh air, and it cannot be recycled. That means if I'm in a math class, about 80% of the air is recycled from another part of the building. In a science lab, 0% recycled. It's always fresh air, and rightfully so, given the hazards and the potential risks that are involved here. Exposure, all right, the TLVs, the PELs, communication, fume hood hazard control measures, prior approval process, designated personnel responsibility, safety training right in there, and medical consultation and examination. All of these are required components for your plan. So if you have one in your district, you better check it over, make sure that those pieces are in there, because legally it is required. Next. Safety qualification training. Under OSHA 29 CFR 1910-1450, science educators are legally required. Okay, this is a legal issue. Have annual appropriate safety training provided by the employer, I will add. That doesn't mean you can't have a consultant come in, but it's required by the employer to provide it. Receive safety training upon initial hire. Notice when you're first hired, you're walking into that school, you need to be safety trained relative to the lab safety program and the plan. Receive safety training upon any new assignment. Let's say you're teaching biology and in the spring you get new assignments for the following year and, oh, gee, they have one section of chemistry that they want you to teach. Oh, the bell goes off. You're supposed to have additional safety training to better meet the needs of that new assignment. They don't offer it. You tell them you must have it. It's the legal piece. Receive safety training when there are no changes in the chemical, when there are changes in the chemical hygiene plan, and receive safety training when there are new hazardous chemicals in the chemical inventory. So it's basically, as we said, it's an annual event, and there's a lot of different reasons that they need to do that. Now, key finding of some study that was done by, I think I know who that did that. 35% of teachers of STEM and CTE do not have any formalized safety training. Can you imagine that? 35% never got formalized safety training. And completing formalized safety training, those if they got it, those who got it, you can reduce accidents over 50%, 51%. That's huge. Okay, so this is why we're saying training absolutely required and necessary. Next. Oh, one of my favorites. Look at this. I mean, if you listen, you can hear that room screaming out, help, help, help. I mean, it's just that this is a sin, literally. This is a sin. Because anybody walking in there, you're lucky if you're able to get back out alive. And I'm not lying about that. I mean, look at the crap. I mean, I'm sure you need Drano on top of the flammable liquid and acid cabinet. There's a real no-brainer. You can see some of the labels are missing. I mean, there's just crap everywhere. Nothing. Poor housekeeping. OSHA has a housekeeping standard. All right. Look how on top of it. First of all, look at the acid cabinet on top of a flammable. Oh yeah, that's really secure. Notice it's blocking a doorway. I don't know where it's going, but you never block doorways. Okay. Look at the top of the acid cabinet. Look how balanced that box is, that cardboard. Look at it. It's half in the air. I mean, just craziness. This is craziness. You should never, ever work in this type of environment. All right. Now, I'm not going to say that you aren't going to inherit it. Going into a new school district, you might inherit this. Somebody who's been there for 40 years, this could be where they're at, which is unfortunate and extremely unsafe, right? So for your own health and safety, please, please, please don't do this. Don't create this kind of an atmosphere because somebody is, including you more than likely, is really going to get hurt. And I'm talking seriously. And it's not only the things you see, it's also the things you can't see. the vapors, the particulate, et cetera, that are being given off by some of these bottles of crap that's in there. Okay. This is just another view of the same thing. Now you'll notice here on the right-hand side, all right, in the storage shelving, if you look on the far right, second shelf from the bottom, look what's growing on that bottle. Isn't that interesting? Yes. This is not a biology class where the plants grow. Those are crystals, all right? Not good. Not good. That bottle is telling you something. Okay? It's telling you something. Get me out of here. All right? Get me out of here. Not good. So you need to be very careful of that. The other thing is you'll notice there are some things that are one thing on top of another. No, you don't store that way. You don't store that way. Now, I will say one positive is they do have lips on the shelving. So that's a good thing. Okay, so they can't hopefully fall out unless they're balanced teeter-totter on top of another bottle or container or whatever the case, right? The other thing is you want to make sure you have dates on all of these bottles, which I don't see. The reason being, obviously, that with age, some of these bottles, the chemicals get cranky, so to speak. And again, you go to pick it up and we've had instances where they literally have exploded in people's hands. Okay. You don't want to go there. Seriously. You just don't want to go there. So again, this is poor housekeeping. You're not following legal safety standards, better professional practice. And if somebody else gets hurt and this was your responsibility, you're it legally. You don't want to go there. All right. Because you'll either be negligent or even worse. You don't want to be reckless. And reckless is when you knew it was unsafe and yet you left it that way. Not good. Okay. Inventory management. Managing the inventory. Ensure that there's an accurate chemical inventory. Accurate means up to date. Appropriate. When maintaining the inventory, any chemicals that have exceeded their shelf life must be disposed of following the proper disposal procedures found in the SDSs for that chemical and directions in the chemical hygiene plan. There should be an SDS for every, notice it's capital intentionally, every chemical in the inventory on site. And these need to be kept for 30 years, believe it or not. Right? OSHA requires a minimum of 30 years. You're required to hold on to the SDSs. So that means the 2016, when we switched over from MSDSs, you can't get rid of those MSDSs. All right, you have to keep them for 30 years. All right, just like the SDSs. Any chemicals have broken lids, damaged vessels, bottles must be dealt with immediately. That doesn't mean tomorrow, next week, or next year. Immediately. Any liquid spilled must be contained and handled in accordance with chemical hygiene plan, chemical spill safety protocols, and ensure that all accumulated chemical waste have been labeled and are scheduled for hazardous waste cleanup. Now, speaking about scheduling, if it's not an absolute crisis situation, certainly we have annual hazardous waste cleanup, right? That's when they remove the end of the year. If it's something that is going to be explosive, it may be immediate, you don't know, you get rid of it right away appropriately. All right. So it depends on what it is. So you need to have knowledge, again, using the safety data sheets and the like. Now, the only last thing I'm going to say, you'll notice the shelving here on the right. What happened to the lips?
Oh, Ken, I'm glad you brought that up because I took this picture because I had them make those plexiglass lips. And if you look at the top, you'll see it easier.
Oh, I can see that. I'm sorry.
They were made in the shop at the school by the CTE students who measured everything, and that's what those little the four screw holes are across the top.
Oh, yes.
In there. So yes, I'm glad you caught that, my friend.
Yeah.
I'll take the gold star for that one.
So I don't know if it's good to have them transparent. Oh, anyways, let's move right along.
It meets the standard according to James Falsing.
Evidently. Anyways, how many chemicals are actually needed? Most
Great.
academic, what?
That's a great question, Ken.
You like that, huh?
Love it.
Most academic chemical storerooms have an abundance, that's an understatement, I might add, of chemicals on hand, often in excess of 300 bottles. I've seen over literally almost 1,000 in a few cases. Many of these are not used and are considered older. You can offer a very robust chemical program with approximately 75 chemicals total, with 15 to 20 used often and the remainder consumed only once or twice each semester. Use the color dot method to visually dashboard this in your science department each time you use a chemical to identify those compounds which are not used at all. Now, I am going to make a little note here. It partially is based on the types of program curriculum requirements that you have. You may have certain types of sciences that do require more than just 75. So just be aware of that. I mean, this is on average, and I would agree with that. But there are instances where you may need to have, especially in advanced courses, certain types that would require more chemicals for use. But again, it's the same story. How long do you keep them, right? And the dot system is a great way to keep tabs on that. Really good. Okay. Storage concerns. Having too many chemicals on site, overcrowding of chemicals on shelves or in safety storage cabinets, alphabetical random storage. Please, please. I couldn't tell how many schools I go in to inspect and I find chemicals in the chemical storeroom totally alphabetical. Just craziness, especially when the H's are on the top shelf, way up on top near the ceiling, which they shouldn't be to begin with, as in concentrated hydrochloric acid. Oh, you don't have that in an acid cabinet? And I've also seen sulfuric, the S is up on top. There's the concentrated sulfuric acid. And you're taking your life in your own hands, right? And a lot of teachers are too short to even reach up there. So they'll stand on something, not necessarily a step stool or something unsteady, and they're reaching way up there. Oh yeah, that's real smart, right? Not having appropriate safety storage cabinets for segregating flammables, bases, acids, toxins, old chemical inventory. As far as I'm concerned, old chemical inventory is more than 1 year, but we'll say 3. Poor or lack of GHS appropriate chemical labeling and lack of safety data sheets, incompatible chemical storage systems. All these components are critical for appropriate storage. All right, you need to address these. You need to address them so things are stored appropriately. And speaking of storage guidance or guidelines, solids, low tendency for reaction, well, that's good. So most can be stored alphabetically, and again, there are exceptions. Sulfides away from acids, cyanide compounds away from acids. I'd be very careful even having them in your inventory. Phenol crystals away from oxidizers, reactive metals stored in flammable cabinets, okay? Very important. Liquids, toxins, and non-flammables can be stored together. Others must be separated by class. Organic acids, separated from inorganic, bases, oxidizers, flammables, okay? So again, all this stuff is really important, and this should be part of your training. Segregation of chemicals is critically important for safer storage practices, okay? Follow procedures in a chemical hygiene plan regarding the storage guidelines for your local schools. Be consistent in your department about chemical storage. By that, we're saying, well, gee, if I look in the biology chemical storeroom, should it be the same as the one in the chemistry storeroom? Yes. All right. This is one shoe fits all. It all should be the same. Okay.
Again, I want to make one comment about those reactive metals, the calciums, the lithiums, potassiums, sodiums, etc. Those do need to be stored, yes, in a flammables cabinet, but they must be stored under oil, under light mineral oil. They cannot just be stored because they will react with the moisture in the air. They'll react with the
Correct.
sebaceous glands from your skin. That's why you have to follow all of the PPE that's necessary in Section 8 of the SDS and be trained in how to handle that in a safer manner.
Another
Many,
one,
many
oh, I'm
accidents
sorry.
could be prevented. No, I'm sorry, Ken, you go ahead.
Yeah, another thing that I sometimes see is pod bottle gas, right? The small cylinders. Now, I'm not talking the large ones, but the very small ones,
The lecture cylinders,
the
yes.
lecture type, right? If those are flammable, all right, it has to be in a flammable cabinet, but not with any other flammables. OSHA is very specific about that, right? You cannot have it in with all other flammables in a flammable liquid cabinet. It must be in its own cabinet, flammable cabinet. Just want to make a point of that.
Yes, for those compressed
Okay.
gases,
Yep.
absolutely. Okay. Thank you, sir.
Chemical labels, SDSs. All chemicals in a laboratory and chemical storeroom must have an appropriate chemical label and associated safety data sheets. Since 2015, chemicals ordered from responsible chemical suppliers are affixed with GHS, Globally Harmonized System labels, and the SDS safety data sheet. When you create a diluted solution, for example, 0.75 milliliter HCl from a 6 milliliter stock bottle, the new dilute solution also requires legal label and generic SDS. Even small dropper bottles must have labels and SDSs. We had a situation even in my own school district recently. The fire marshal came through and he contacted me. He says, geez, he says, I just happened to go through the science building and I noticed in one of the labs the teacher forgot, because this was after school, and left some chemicals out. And I said, you are right. The teacher was in error, forgot. And I contacted the teacher because we do have legal safety standard, better professional practice. You don't leave chemicals out. You put them away and you make sure that they are labeled. And so something else he said, there were a few bottles that were not labeled, right? And any label, and here, teachers had been trained a number annually and just unfortunately forgot. And so, but we rectified it and it moved on. I mean, there can be a lot worse things, but so I mean, it even happens in schools where they get a lot of training. Okay.
Dr. Ken, a question came in that it's this. I'll read it. We have 300 chemicals. Do they all need a GHS label?
Every chemical must have the appropriate labeling. Every chemical, all 300, yes.
So I'll take that a step further from my experience. But only 100 of them are current. The other 200 are from 2005.
Oh, well, that's different.
Is it different?
Yes.
Please explain.
OSHA said that they are grandfathered.
But the second that they create a new solution on site or purchase a new
Oh,
one,
that's that again.
yes,
Now
be.
you're in current dates. If you're in the current date, then you must use the appropriate GHS labeling. But if you bought these years ago, you're not required to go through and sorry, no summer work. You don't go through and change all the labels. They are literally grandfathered. I know this specifically from OSHA. They told me.
Certain jurisdictions will, though, for consistency, want them all the same with the pictograms, and that's fine. That's more of a better professional safety practice than a legal safety standard. So, thank you for clarifying that.
No problem.
Do my best.
I try. Anyways, chemical waste management. Now, unfortunately, this is a part of the game, so to speak, that often is ignored or not thought about until the last moment. And I hate to say that, but it's true. Chemical hygiene plan in your school district will contain a procedure for handling chemical waste in accordance with your local jurisdiction, wastewater, EPA, chemical neutralization, and other threshold and legal safety standards. These procedures must be followed, right? Keeping these accumulated chemical waste isolated, separated from your commonly used chemicals is critically important. Make sure to have a label indicating the chemical name, molarity concentration, and the date it was created. Do not mix chemicals unless you are sure about their incompatibility, as some reactions can be violent. Absolutely. Notify the chemical hygiene officer about waste. Again, be smart to put it in writing. Don't whisper in their ear. Put it in writing. So you have it in writing, it must be written, it will be done. Believe me when I tell you this. All right, so
And I would say the big takeaway is make sure to label exactly what that is with your name, date, chemical name.
now, having said that, there may be instances of chemicals you have inherited and you have no idea what they are and nobody else on the staff does. All right? You still put a label unknown on it. All right?
Right.
Unknown. You
And
have to do
designate for
that.
disposal. That's right.
Right? Because you do have those kinds of situations, and it's unfortunate.
Thank you, sir.
Chemical purchasing and ordering, another important element of the CHP is purchasing and procurement process for chemical ordering. Follow these general guidelines for chemical purchases. Order in the lowest volume and molarity necessary to minimize potential accidents. Right now, unfortunately, and I hate to say this, but as teachers and even curriculum directors know, you don't always know exactly how much money you're getting in your budget annually. Even though you request a certain amount, very often it's much less. But every once in a while, you get bonus years. And what teachers do when they get that little extra that they have, they buy over amounts of what they really need to save it for the rainy day when they're not going to have the money. And that's how we get into trouble. All right. We went to one district and it was a middle school and they had some hazardous chemicals. They had methanol and ethanol, all right? 20 gallons. 20 gallons of this stuff. It must have been there since the beginning of time. I probably could have done a carbon-14 dating on it. And I said, help me understand, why do you have all it? Well, we never know how much we're getting money-wise. I said, obviously, this has been going on for quite a few years. Yeah, it's just craziness. You just move on. You can't do that. It's unsafe. Consolidate orders across the department to minimize duplicate ordering. Ensure you have appropriate facilities for the chemicals ordered. Those, make sure you have room for them. Make sure if you have acid cabinet, you got enough room in the acid cabinet. Make sure you have appropriate ventilation, et cetera, et cetera. Restricted chemicals may require prior approval from the CHO. Actually, in many districts now, it is the CHO that has to approve all of chemical purchases, which I don't think is a bad idea. And it also helps to protect the teacher if the CHO is helping to make that decision. So again, and I like the diagram that's attached there. You'll notice purchasing, very, very important, and it's a nice cycle to do. You have identify need, purchase requisition, approval, purchase order, goods, services, receipt, invoice, match payment. So, I mean, that's the cycle of purchasing. That's the way it is. It should be that way. Next.
I want to just put in one more little pearl in here. Never accept donations in your department. Never. I mean, you're just accepting someone else's liability and their problems. Don't do
it. It becomes your problem. And I've seen situations where literally it has cost a school district several $1,000s to get rid of chemicals that were donated from some company in the town that the school was in. You don't want to go there. And you know what? Don't think for a moment that you're going to be able to give them back. They're going to say, "No, I'm sorry, that was a gift. That's yours." They're not going to take it back because they knew when they gave it to you. Trust me.
Oh, exactly. I think Ken. I think that was the word in that is called custodianship. Isn't that the word they use?
Yeah, well,
Whoever has custody of the chemical is the
well,
one responsible for it.
that's the truth. Next. Appropriate PPE for all occupants, anyone in that laboratory instructional space, anyone, whether they're a special ed para, a volunteer, the teacher, all students, doesn't matter. Anybody in there is required to have appropriate PPE, right? This includes the indirectly vented chemical splash goggles, meaning the ANSI ISEA Z87.1D3, which must be worn when handling hazardous chemicals, bioliquids, and the potential to splash the eyes. And remember, 3 parts. The startup, you're gathering the stuff, the hands-on, and the takedown. Goggles or safety glasses with side shields can be used when working with physical hazards, as I mentioned before, if you're using power tools, hand tools, springs, glassware, et cetera, et cetera. Nitrile gloves and non-latex lab aprons or a lab coat appropriate for the material shall be worn when using chemicals, biologicals, heated items, certain tools, etc. PPE is required during the setup. Here we go. Setup, hands-on, takedown segments of the activity. Use of hand protection in school science instructional spaces usually means appropriately signed nitrile gloves for all occupants. Okay, not latex gloves. Now, you'd be wondering here, I've been using the term instructional spaces, science, laboratory instructional space. Now, we all know you may have just a science classroom, not a formal lab. So that's a classroom instructional space. In science, often demos are done there, and even sometimes hands-on lab experiences are held in a classroom, right? So the point here is any instructional space in science, right? You're required to have all of this appropriate PPE when those kinds of activities are going on. For specific hazardous chemical PPE requirements, consult the safety data sheets, section 8 for appropriate PPE use. Make sure PPE fits people in the room, all right? Fit. In other words, you don't have extra large goggles on middle school kids or especially elementary kids. You have the right size, make sure they fit appropriately. Same thing with gloves. You don't want the gloves falling, the extra large, you don't want them falling off their hands when they go to use it if they only have a regular or small size. These are available in different sizes for a reason. Okay.
Again, I want to go back to your three-pronged approach there, the setup, hands-on, and takedown. Let me give you a scenario. If 2 groups finish their lab investigation, are they able to put away all of their equipment, apparatus, materials, and take off their safety gear?
I know where this is going.
Okay, then I'll let you answer that one.
I always had a rule. When my PPE came off, yours can come off, right? And that is the rule. It doesn't matter just because you're done that you can't have projectile motion. Somebody in the next group over is still doing theirs, and you can have a projectile come and get you right in the eye, and could be burned, could blind you, whatever. So again, the point is teachers should have rules, behavioral expectations. When their PPE is on, the kids have it on. When they take theirs off, the kids can then take theirs off. Don't assume just because, and I don't care if you just have one group left, everybody keeps it on.
Great answer. I support that answer, Dr. Ken.
Well, that I'll sleep tonight. Chemical hazards in emergency situations. Every chemical in your inventory will have an appropriate GHS label and corresponding safety data sheet. The procedures you need to handle emergency situations involving these chemicals is outlined in the 16 section SDS. Refer to these specific sections as needed. Section 4, first aid. If somebody gets hurt, How do I apply for? What do I do? And don't think from oh, we'll wait for the nurse. First of all, is the nurse in the building? Number two, how far is your lab from the nurse's office? There's all kinds of possibilities. So it'd be good as long as your Board of Education allows it for you to be trained, in which you should be at the beginning of the school year. Section 5, firefighting measures. God forbid you have a fire. Have you been trained to use a fire extinguisher? You're required by the law, fire code wise, to be trained if you're going to use it. In some instances, if you determine that even using an extinguisher, the fire is too big or potential for explosion, leave it. Just get out alive as soon as possible. Don't wait around, right? That's part of firefighting, all right? You don't necessarily stand around to fight the fire. It all depends. You have to make a judgment call. Accidental release measures, steps to take in event of a spill or release involving a chemical, emergency procedure, protective equipment, methods for containment, certainly in cleanup, handling and storage, precautions for safe handling and storage, including incompatibilities, and exposure, section 8, exposure controls, personal protection, which I've already mentioned. Again, these are all really, as JP states, pearls that will help you to address chemical hazards and emergency situations in dealing with them.
And that is the end of our segment so far this evening. We'll have a question and answer period in just a moment, but I'd like to take a minute and just let you know that Science Safety and Accelerate Learning have partnered together to provide access to safety solutions and services all across the K-12 educational space in the USA. Accelerate Learning is the exclusive partner for our products, and together we are making schools safer through education and awareness. Please contact Accelerate Learning for more information or to schedule a conversation. Accelerate Learning is the parent company of STEM Scopes, which you may recognize from your day-to-day activities in the school. There are the references that Dr. Ken and I used, and Dr. Ken used in creating this particular presentation. And now it brings us to my favorite time of the webinar, which are questions for the presenters. And Ken, a few questions have come in. If you have a few moments, I would love for you to answer these questions. Are you ready?
Do it.
All right. James and Dr. Ken, I found some radioactive samples in my prep room. What do you suggest I do? Question mark.
Well, that one is actually personal for me. When I first started working in Glastonbury Public Schools several decades ago, in the middle school, I happened to go in the chemical storage area, and they needed some help with that, most certainly. They then had a storeroom, a science storeroom. So I went across the hall, went into science storeroom. Well, in the back, way up on top, I see the radioactivity sign. And I said to myself, this is not going to be good. So I very carefully just went up and looked, and sure enough, they had radioactive materials. The dates of which were not all that recent, but the point was this. What I did was, and just about every state has this, I'm sure all of them do, radiological officers, they're the ones you need to contact, all right? Possibly in your State Department of Health or the State Department of Labor, whichever there happens to be, I'm sure you can find out. And you should invite them in as soon as possible, I might add. And it just happened that the ones that I found were still active. Let's just leave it at that.
Understood.
I'm sure if I had shut the lights off to the class next door, some of them would be glowing. No, that's not true. It wasn't that bad, but you never know. You never know. And I know instances, there was a case in Massachusetts, an EPA guy with consultant was coming in to speak to a chemistry class and had, oh gee, the meter and Geiger counter, and was walking down the hall and just happened to have it on. And he goes by the earth science lab, and the thing just going crazy. He's like, what the hell? Goes into the room, finds these rocks that are being used as paperweights, uranium ore.
Perfect.
Unflippin' believable. And I mean, it was really singing out a song on that Geiger counter, and it led to lawsuits. And I mean, the exposure level was unbelievable. Teacher was collected them, but was unaware. Don't collect rocks unless you can ID them. That's the bottom line, obviously.
Absolutely.
Right? Because there are dangerous things out there, and you don't bring them into the workplace. So yeah, I hope that does help. Seriously, a radiological officer, that is your best bet, very seriously. And just they will tell you, in fact, they probably help you get rid of it if it's a danger. But you need to do that sooner than later, because if you don't know how strong the level is on there, get that person in there right away.
Great. And do you have time for one final question this evening?
Of course.
Thank you, sir. Dr. Ken, I found a box with 7 old mercury thermometers.
There we go.
How do you suggest we dispose of those safely?
All right. Well, my first question is, are any of them broken?
Let's assume not.
Okay, we're going to assume not. If they're not broken, what I would urge you to do is to contact a company that deals with hazardous chemical waste. And it's worth the money to hire them. Don't bring them out to the football field and bury them.
Exactly right. Exactly right.
This is a big responsibility. Now, if there is a case where it's shattered or whatever, in some states, depending how many teaspoons of mercury there are, you have to evacuate the school, literally, and the fire department would come in and they would take care of that. All right. So just please be very careful. Make sure they're well packed wherever you had them, secured, locked. Have a lockdown on them so kids can't get at them and other teachers can't get at them. All right. They shouldn't be there. That's my advice.
All right. I would contact the chemical hygiene officer as well and let them know what you have discussed.
Oh, yeah, absolutely.
Right in your
don't go solo.
Correct. Collaborative effort and over communicate that for sure.
Yeah, very much.
For sure. Well, Dr. Ken, it has been my privilege and my pleasure to spend an hour with you. Thank you so much for sharing your wisdom, your experience with all of us. And I think our schools will indeed be safer starting tomorrow morning.
Hopefully so, sir. Hopefully so. And I want to thank
everyone who attended again. Or go ahead. What's that?
Everyone who attended tonight, and please be safer.
Very good. Stay safer, my friends. We'll talk soon.
Take care.